Hello there, algebra students. This is Mr. Kashi speaking. With this video, we're going to be going through a handful of examples of how to graph a parabola. This can get a little confusing, but there's a certain amount of steps that if you follow every time, it should be pretty painless. So, the first thing that you need to know before you start graphing a parabola are two things. One is what standard form is, and this is just how we would write the parabola's, the quadratic equation to graph the shape of a parabola. And then the other thing is the formula for the axis of symmetry, and that's going to be rather important because that's our first step, is we're always going to find the axis of symmetry using that little formula. What we say is opposite of b over 2a, and that's taking the b and the a from your standard form equation. And then once we have that, that will be put in two places. So on your graph, you can write your axis of symmetry. It's usually a dotted line, like this orange one right here. And then we're also going to take that value and we're going to put it in the middle of our table. And that is going to be our x value. Then we can plug it into our equation and get a y value. And this is going to be our vertex. And then after that, we're simply going to plug in two x values before our axis of symmetry and two x values after our axis of symmetry. And then we will have a total of 5 points. We always want 5 points for a parabola. And really a lot of the work here is just plugging in all of these. It's going to be here, plugging in all of those x values in your equation. Plotting the points goes pretty quick, but yeah. So I wanted to go through a handful of different examples. We'll start off pretty easy and then get a little bit more complicated. But I wanted to. This video might be a little bit longer, so feel free to pause it whenever you need to stop and take some notes. So here, we have our standard form ax squared plus bx plus c, and we have f of x equals x squared plus 1. And just a reminder, f of x and y are pretty much the same thing. Now this is a pretty short equation, so I want to write in the different things that we don't know. So I would rewrite this as 1x squared, because our a is going to be 1, plus 0x, because we don't have a b term. We don't have that x term right there, so we don't have a b, plus 1. And so using our axis of symmetry formula, we have opposite of b, so that it'd be opposite of 0, over 2 times a, which is 1. Well, this is just going to be 0. Anything that has a numerator of 0, in this case it's asking for the opposite of 0, which doesn't exist because 0 is just 0. So remember, this axis of symmetry goes in two different spots. We're going to put it on our y-axis right here, because x equals 0 there. And then we're also going to put it right in the middle of our table. So we have 0 right there. And then what we need to do is we need to plug in two numbers before. So we have -2, -1, and two numbers after, 1 and 2. And we have to plug all of those into our equation right here, and we'll get our y values that we can plot on the coordinate grid. So I'm going to start with the vertex. So I'm going to go 0 squared, which that should be pretty easy. That's just 0, plus 1. So we get a point of 0, 1. So my vertex is going to be right there. Then I'm going to show you all 5 points here, but later on in the examples I'm going to show you why you wouldn't need to do all 5. So here we have -2 squared plus 1. Well, -2 squared is 4, plus 1, that would be 5. So that would be -2, 5. Right there. It'd be a point, and we can plot it just like that. -1 squared would just be 1, plus 1, that would be 2. So just be -1, 2. And here we would have 1 squared plus 1. So this would be 2 as well. So that would be 1, 2, 1, 2. And then we have 2 squared, that's 4, plus 1 is 5. So it'd be 2, 5. And hopefully you can see how this has been very symmetrical over the axis of symmetry. That's why we call it the axis of symmetry. All right, and we can just draw our curve in. It's going to look something like this. And it's going to keep going. We're going to have arrowheads at the end each there. And one thing that's going to save us a lot of time is hopefully you can see we do 2 before and 2 after because they're the same thing. They're just mirrored. This 2 is the same as that 2. This 5 is the same as that 5. So in all reality, later on we probably wouldn't have to do 2 of these calculations. We're just going to do 3 calculations and then kind of flip them over. So that's graphing the parabola x squared plus 1. Our next example is x squared plus 2x minus 6. So first of all, we're going to have opposite of b, so opposite of 2, over 2 times 1. Remember, there's a 1 out in front right there. Okay, we just don't see it, so but it's important that we know that a is 1 in this case. So this would be negative 2 divided by 2. This would be negative 1. So this is an important negative 1. It means 2 things. It means that we're going to put our axis of symmetry at x equals negative 1. And we're also going to put that right in the middle of our table. We're going to go 2 before and 2 after, so this would be negative 3, negative 2, negative 1, 0, and 1. So let's find our vertex first. That'd be this first, the one in the middle. So we have to plug it into this equation now. So we have negative 1 squared plus 2 times negative 1 minus 6. So the first, that would be negative 1 squared, that would be 1, plus a negative 2, so that now we're at negative 1, and then that would be negative 6, so this would be negative 7. Sometimes what I would prefer to do is I just like to write them out right here and not plot them quite yet. I'll just plot them all at the same time. So now I would prefer not to have to deal with negatives, so I'm not going to do these first 2. I'm going to bump down here and do these last 2. So we have 0 squared plus 2 times 0 minus 6. I do that because obviously plugging 0 in makes the arithmetic a lot easier. So 0 squared is 0, 2 times 0 is 0, so we just have this negative 6 right there. And then what you can do is you can just put that negative 6 right up here because of our symmetry that we are creating with our axis of symmetry. Then down here we have 1 squared plus 2 times 1 minus 6. So we have 1 squared, that's just 1, plus 2, that'd be 3. 3 minus 6, this would be a negative 3. And once again, we can put that up and put this negative 3 right there. So I'm going to go ahead and plot these points. So we have, negative 3, negative 3, negative 2, negative 6, negative 1, negative 7, 0, negative 6, and 1, negative 3. So then you can just connect your points like that. So now we have a parabola looking like that. And we didn't have to fill these in because of our axis of symmetry. That's going to save you a lot of time. So I wanted to go through 2 more examples. Like I said, go ahead and pause this whenever you need to. I think this is only going to be our last example. So here we're having opposite of b, so that'd be negative 6 over 2 times our a, which is negative 3. Sometimes it's easier to kind of go through over to the side and just say, okay, a is negative 3, b is 6, all that kind of stuff. So here this would be negative 6 divided by negative 6, which that would be 1, which means that our axis of symmetry is 1. So we're going to write that there, and I'm going to put a 1 right here as well. So plug in for our x values, 2 before and 2 after, so this would be negative 1, 0, 1, 2, and 3. So then I'm going to, this a little bit longer, we got negative 3, 1 squared, plus 6 times 1 minus 1. So 1 squared, that would be 1, times negative 3, that's negative 3. Negative 3 plus 6, that is 3. 3 minus 1, would be 2. I'm not going to do these bottom two because I think these top two are going to be a little easier to plug in. So we have 0 squared plus 6 times 0 minus 1. So here we have obviously 0 plus 0, and then we have a minus 1 here. And then here we have negative 3 and negative 1 squared plus 6 times negative 1 minus 1. Okay, so negative 1 squared, that's 1. 1 times negative 3. Negative 3 plus negative 6, that would be a negative 9. Minus 1, this would be negative 10. So obviously with these calculations, they get a little bit longer. So if you need to use your calculator, please go ahead and do so, but make sure that you're using parentheses just how it's written here. And then I can run these down, go negative 1, and I can do negative 10. So in this case, we have negative 1, negative 10 all the way down here, 0, negative 1, and then we have 1, 2. That's our vertex. And we have 2, negative 1, and we have 3, negative 10. And hopefully you can see how this shape is a little bit different than the ones that we've been doing. And we're going to talk more about that later, of why it's like this, but hopefully you can see that this that negative 3 is why it is that this is so stretched vertically. We call that stretched vertically. But we'll talk about what exactly that means in a later lesson. So I just want to double check. Yeah, that was the last example. So I had said 2 before, but we only had 1 more. But hopefully these examples, hopefully starting with a few easier ones, moving on to this a little bit more complicated one, helps you with your assignment. And like I said, feel free with these in here. These are some important calculations. So if you need to use a calculator, make sure you use in parentheses. So hopefully these help, and good luck on your assignment.